Hello, and welcome to the Introverted Manager. Today I will be exploring interesting case. I have one table and I have second table, and I need to append those two tables. But the thing is, there are some differences either in data types or columns, and I would like to see those differences. There are different ways to do so, but today we'll be exploring how to compare those two and explicitly mark those discrepancies either in columns or data types between two tables in Power Query, directly there, without leaving Power BI. Let's dive right in. Let's see the model, or what we'll be working with today. It's a Cantoso database, although it doesn't matter much in this case. So I have product table with multiple columns: product name, brand, manufacturer, color, etc., category, subcategory. And I made copy of the same table. However, this time around I made some transformations. So as you can see here, I changed some data types for a few columns. I removed some columns, and I also added a custom column and also renamed one. All of this for the sake of example. So now those two tables are different and I would like to compare them, which I will be doing here with Power Query. As you can see here, I have two parameters. First parameter specifies table 1 that I would like to compare, it's just the name of the table, and parameter table 2, which specifies my second table. And this is the result. That's where we will arrive. As you can see here, I have all of the columns listed. It shows whether it's present in product table, whether it's present in product alternative table, whether there is some mismatch between the two, data type in the first table, second table, and again, if there is type mismatch. So you can easily filter just two results where, for example, you have either column mismatch or type mismatch. Let's see how it's working in the backend. So I'll go to Advanced Editor to see the M code. And there are quite a lot of steps, so be patient with me. So first one is save table name. The thing is, those two parameters, and maybe let me switch to parameters so you see, those two parameters are just simple text. Unfortunately, I would love to make it a drop down, but Power BI does not allow those drop downs to be dynamic. So this is the way, at least for now. First thing that I do is I extract table name, but it in a safe manner. Reason being is that my second table has some spaces but also special characters. You know, the dash. Therefore, it has to be done in a safe way. Otherwise, there will be errors. I will show you the errors. If I just do save table name 3, and I remove that safe extraction or those extra. Let me do this. Table 2, and let's see what it will produce once I click done. This is what it produces. So just the text, but then I have to reuse that later on as a reference to a table. Since it has spaces and special characters, I have to add additional characters. The ones that you usually see Power Query adds itself for such references. And let me add it here so you see. In the end, the string that I should produce should look like this. And product alt. This is how it's supposed to be in the end. That's what I'm adding here and here. So I'm concatenating few additional characters in the beginning and the end. Anyways, let me remove this and let's move on. Then the next thing that I do is I'm preparing sources. Again, from parameters, I'm extracting text. So it's not yet full reference to the table, it's just a text. Because of that, I do expression evaluate. So it evaluates the text and then finds that it actually refers to table name. And now, in source 1 and in source 2, I actually have reference to the table. Also here, you see shared function. What it does is actually produces all the, and let me maybe add here another shared statement to see what's the result of its evaluation. Let's go here. It shows you all of the tables, functions, etc. All of the M-related assets within the model itself. All the inbuilt functions, all of the custom functions that you produce, all of the tables, all of the parameters, everything combined here. Okay. Again, let me delete it because I don't need it here. But I'm evaluating this table, my table 1 and my table 2, from the list of those assets. I don't know how to call it properly. Okay, let me remove it again. Let's move. So this is all still preparation. We're not doing anything yet. Now the next step will be to extract columns and data types from those two tables. So that's what I'm doing here. And this is the first step that is evaluated. I'm extracting schema. Schema is service parameters for the table. This is an inbuilt function into M. So from the table, my table, I'm extracting those service parameters. Namely, I'm selecting certain columns. Those columns are name and type name. So names of the columns and also their respective data types. Great. This one, namely, if you remember, let me close it and go back to the table. If you remember here in column names in the final table, the resultant table, I mentioned present in and name of the table. If the table will be named differently, if I'm, for example, comparing store or sales, it will have relevant name. This is just to make it easier on the user in the end to compare the two. So you know exactly what is what. So here I'm dynamically building that column name string. This one is for type in columns, the ones on the right. So just dynamically producing the name. The next step is just simple rename. Again, we're still doing the prep, the initial prep. So table, rename columns. I'm taking the virtual table that I created in this step where I extracted two columns, and I'm renaming name column to column name and type name to that dynamic one. Type in table 1. Okay. The same thing happens for table 2. Absolutely the same, no changes here. Now, what we need to do next is to make distinct list of all of the columns for two tables combined. Because later we will be doing some joins with those columns. So what I do here is I first combine those two tables, or specifically first columns, which contain column names. You can see it here. Column name from table 2 and from table 1. First I'm doing combine, and then I'm executing table distinct on top of that combine. In the end, I have list of unique columns in those two tables. Okay. What I do next is join. And there will actually be two joins. So I take that list of unique column names, and then I join first table 1 to see which names are present from table 1. And I'm joining table 1 schema. I'm joining table 1 schema. So I'm joining full list of columns with table 1. So there will be less columns or different columns, etc. And since I'm doing left outer join here, as you can see, it will produce, if column is present, it will be listed, otherwise it will be null, which we'll use later on. Okay, and then just doing the expand. Moving on, we're doing the same thing with table 2. Again, it will give you, and maybe let me walk through some steps here so you see intermediary results. So type in schema, distinct columns, as you can see here. It actually have columns from both tables. Then merge table, and let's see what happens after expand. The types for columns that are present in table 1. Then the same happens for table 2. Then in step 6, I'll be checking for presence in either of the tables. But first, again, I'm doing dynamic column names. Present in table 1 name, table 2 name. Then next code is checks for the present. And here I'm relying on type columns actually, because if this column is present, the type won't be null. However, if it's not present, it will be null. That's what I'm checking here for. So taking data type column, and if it's not or other than null, then it produces either true or false, because the type is logical here. This function returns value of the specified field, nothing else, just a reference. And then I'm expanding the table that I'm gradually building. Table, add column, I'm specifying the table that I'm extending. It's the table that we've built here with data types, and I'm adding new column present in product table. And for values, this is what I'm producing. Same happens for table 2. Same logic. Now, additionally, I am adding extra column, which shows if there is data type mismatch. Yes, you have listed data types for table 1, you have data types for table 2, but also if you want to filter and see only results with type mismatches, I'm adding column with this. So add mismatch column, and the condition itself is if data type column does not equal data type table 2 column, it produces true or false because of that condition and type logical. This one, again, this one is needed just because I'm building column name dynamically. If it was static, for example, just data type 1, data type 2, I would just specify here column name. And I'm doing the same for columns mismatch. Again, I'm adding column which will show you whether there is some column mismatch happening. So the logic is quite similar. Again, it compares the two, and if they are not equal, then it returns true or false. And actually, now that I see, I probably have to remove data type because I already do that in separate column. So I don't need it twice. I only need this one to show me columns. So, okay. Again, type logical, so it means Boolean, true, false, comparing values in the two, and if there is some difference, it will automatically produce true or false. And I'm calling this column columns mismatch. And by using table add column, I'm adding it into this table, again, which I'm gradually building and adding things to. Okay. And in the end, finally, combining all together. Combining all together, table select columns. From the last one, from the last step, I'm selecting few columns. Column name, present in table 1, present in table 2, columns mismatch, data type 1, data type 2, and type mismatch. And this is the end. Let me press done. And you do not necessarily need last step. However, if you want to sort your columns differently, because that's how it's sorted by default, because that follows the steps from the code. But if you want to sort it a bit differently, which I do, I did select columns in a order that I wanted. So column name, present and product alternative, columns mismatch, type and product alternative, type mismatch. With this, once you have this, you can easily compare two tables and see what's different. This is particularly useful when you have multiple, sometimes large tables with 20, 30, 50, or sometimes hundreds columns, and you need to append the two. But before you do that, you have to align them in column names and data types. Otherwise, it will produce discrepancies, multiple columns, etc., etc. This will help you compare the two. So what we can see here, let me filter columns mismatch to true. And based on this, I see, okay, so in product alternative, I have product codes column. However, in product table, I have product code without S at the end. So I guess I need to rename either in the second table or first table. Or for example, in second table, I don't have color column. Okay, fine with me. And in second table, I have custom column, which is not present in table 1, in product table. Again, could be fine with me as well. Okay, let's delete this filter and let's see type mismatches. True. And okay, there is quite a lot of mismatches. So if you see null, it means column isn't present. However, here, for example, unit cost, this column is present in both tables. In my product table, it has currency type. In my product alternative table, it has number type, decimal type. So I have to choose which one do I have to follow, because sometimes it will result in some discrepancies, or as for example in this case, it will result in errors because one column is in text subtype, another is in integer. So once you append the two or merge or join the two, you will have issues with that. So it has to be fixed beforehand. And that's all for today. Subscribe and see you in the next one. It's a